All right, everyone, welcome to tonight's session. I'm looking at multiplying matrices tonight. And to kick off the first part of the session, in order to multiply matrices, we need to be able to identify how matrices are represented in terms of the number of rows and columns. So on the screen right now, I have written three matrices. I actually wanted to add one more. Let me just write that in one time. Right. What we want to look at basically is we want to look at the number of rows and the number of columns that make up each of these matrices. Once we could do that, we would be able to identify what they refer to as the order of the matrix. And the order of the matrix basically speaks to the number of rows and the number of columns that we have in each of these matrices. All right. So I have three matrices here. I deliberately did them like this. Now, let me just change the color of this pen. Right. So in this first matrix I have here, you would notice that I have, if we refer to rows as horizontal rows, right? So this is my rows, and columns are vertical columns, right? Vertical columns. I have one horizontal row here, and one vertical column, and I have one, two, three rows, right? Now, the convention for writing the order of the matrix or the number of rows by columns is really rows, right? And they put by the number of columns, right? So that would make, therefore, that would mean that this particular matrix is made up of three rows and one column. Similarly, this has two rows, one, two. You see that? One, two. And I also have two columns, one, two. Right? So two rows by two columns to this one. This one has one row, right? One row, one column here, two columns here, three columns there. So this is one row by three columns, right? Because remember, we write in rows by columns, number of rows by columns. And what about this one? We have one row, two rows, three rows, one column, two column, three columns. So this is a three by three matrix, right? So in all we have this one here. This is a one by three. Let's get a different color, right? So this one here is a one by three matrix. This one here is a two by two matrix because there's two rows and two columns, right? This one is a one by three because there's one row this way and there's three columns, one, two, and three. This is a three by three matrix because I have three rows, one, two, three, and then I have three columns. One, two, three columns. Yeah. All right. So now that we identified how we gonna write these matrices, we can now start to get into the actual multiplication of them, right? So I'm gonna take these off. So I'm taking off all of this, all of this, all of this, all of this. Yeah. All off, all off, all off, all off, all off, all off. All right. Now, in order to multiply matrices, right? You just can't multiply any matrices. What we need to do is what we need to do when we multiply matrices basically is we need to see if they're compatible. So compatibility. If you think in terms of relationships, two people are compatible if they could get along, right? Two matrices are said to be compatible if we can multiply them together. And there's a way to check to see if we could multiply a matrix, right? So we want to test for the compatibility of and test for the compatibility of two matrices when multiplying, right? So how do we do that? So we're going to use what I just showed you, right, in order to do that. So to tell whether two matrices are compatible or not, what we need to do is we need to look at the order of the matrix. So let's put some matrices on the board. Let's say I have 2, 4, 6, and 2. And I want to multiply this by, let's use same 1, 2, 1, 3. Before I actually start multiplying, right? Before I actually start multiplying, what I need to do is I need to check to see what the order of these matrices are. So this is a 2 by 2, and this is also a 2 by 2, right? And I got that by identifying the number of rows, right? There are 2 rows here, 2 rows by the number of columns, right? Right? So we have 2 rows by 2 columns. Now to tell whether two matrices are compatible, what we want to look at is we want to look at the numbers to the middle here. If these two numbers in the middle are the same, then we say that the matrix is compatible. If I get my handwriting, yeah? Right? If those two numbers are the same, then we would say the matrix is compatible. If they're not, then they're not compatible and we can't multiply, right? So let's look at a case when that happens. So let's look at this other example here. 1, 6. And I want to multiply this by, let's say, 2, 1, 4, 3. So again, before I actually start multiplying, what I need to do is I need to check to see if these two matrices are compatible. And I do that by writing the order of the matrix. This one is 2 rows multiplied by 1 column. Well, not multiplied, but a 2 by 1 matrix. And this is a 2 by 2 matrix, 2 rows, 2 columns. So if I test now to see whether or not these two are compatible, I am actually going to be looking at the middle. And these two are not the same. They're not, right? Not the same. So this is not compatible. So I can't multiply these two matrices because they're not compatible. They don't have the same numbers in the center here, right? But let me just look at a different scenario. Let me look at another scenario. What if, let me just draw a line down here so we can separate it. Right. So what if I had the other way around? I had 2, 1, 4, and 3. And this is being multiplied by 1 and 6. I know we checked it just now, we say it's not compatible, but things are a bit different with the matrices, right? Because look at this. This is a 2 rows, 2 columns, and this also has 2 rows, but 1 column. Now, when I wrote it this way, things change because now look at this. This is compatible. Okay, take the handwriting and prove it now. This is compatible, yeah? Because these two numbers are the same. So this is the first thing now we need to check to see before we multiply matrices. We need to make sure that they're compatible. Now the next little trick now is something that I refer to as figuring out what the order of the answer is going to be. The order of the answer. All right. So let's look at something here. Now for this first one, right? If I multiply these two matrices together, the answer that I will get will have 2 rows and 2 columns. These numbers on the outside will tell me what is the order, what's the size of the matrix that I'm going to get. If I multiply these two matrices together, my answer for this one, however, wouldn't be a 2 by 2 matrix like in the last one, but it will be a 2 by 1 matrix. Now let's see if we could bring all of this together. Yeah, let's see if we could bring all of this together. So I am going to clear again, clear my drawings, right? And let's look at that first one we had there. right? I might need to make up some new numbers, bear with me. And I want to multiply this by something not too difficult. Not too difficult. What we want here? 3, right? Good. So we know these two matrices are compatible. We talked about this a little while ago. Um, we said that once the middle numbers are the same, we could multiply, right? And let me just double check and show you again, right? So before I actually start to multiply, I write how many rows followed by how many columns. I do the same thing for the second matrix, and then I check to make sure that these two are the same. If these two are the same, then we're good. We could multiply, right? So let me just take that off. Now, how are we actually going to multiply? So to multiply, we need to multiply rows by columns. And when I say rows by columns, I mean matching rows. Well, I shouldn't say matching. Let me show you what I mean. All right, so we want to multiply rows by columns. So look at this. Let's label our rows, right? So I'm going to label rows. I have a different color ink here, right? This row is my, I'll call it R1, right? Because this is row 1. And this row is row 2. So in this first matrix, I'm just looking at the rows. And then in the second matrix, I'm looking at the columns. Column 1 and column 2, right? So remember I said we need to look at the compatibility. So we looked at the compatibility and we identified that it was compatible, right? And the next thing I said is that the numbers on the outside is going to tell me what is the size of the matrix. So my answer, right? My answer is going to be a matrix that's made up of 2 rows, row 1, row 2, and 2 columns, column 1 and column 2. Now I like to map this out for my students because it makes it a bit easier. Now, if I'm going to get a matrix that has 2 rows and 2 columns, I'm going to have to fill 4 spaces. This space here, this space here, this space here, and this space here. And this is what's going to help you figure these questions out, right? How am I going to get the numbers to put inside of here? And that is really easy. Once you understand this part of it, then everything else becomes easy, right? To get the number for here, I need to multiply row 1 multiplied by column 1. And it's easy to remember that because this is row 1 multiplied by column 1. See that? Row 1 by column 1. Very, 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 very easy. Right? So let me just take off that arrow there. Nice. And then I know you're already following with me, so I know you know that for this one, I'm going to have to multiply row 1 by column 2. And underneath here, I'm going to have to do row 2 by column 1. And this is going to be row 2 by column 2. And it makes sense, right? Because here I am in row 1. This is row 1 here. This is row 1. So I should be multiplying by row 1. And if I'm in column 1, then row 1 should be multiplying by column 1. Similarly, when I go to the bottom here, row 2, because I'm now in row 2, should be multiplying by column 1. Across on this side, row 1, we're still in row 1. This is row 1 here, and we're now in column 2. Underneath here, I'm going to be multiplying in row 2 by column 2. So let's see how that actually works out now. Let's look at it, right? So I need a big one of these, and I am doing rows by columns. Now the nice thing about this is that we have 2 numbers in a row and we have 2 numbers in a column. We don't need to use any more than once, right? So I am gonna put here 2, which is the first number in row 1, right? This one here, multiplied by the first number in column 1. I'm putting them in brackets. But remember, I just need one answer for here, right? But I have 2 numbers to add. So to make that into one number, I'm going to have to add these things. And then I'm going to take the second number. I'm going to put in a different shape. Let's use a kind of rectangle here. second number in row 1 is going to multiply by the second number in column 1. So guys, this is all about patterns, right? It's not a difficult subject because what you're doing is just addition and multiplication, right? But it's a pattern, so we have to be able to understand the patterns. So this here, right? Let me just go down one more line so you'd see what happening, right? 2 plus 1 is 2 multiplied by 1 is going to give me 2, right? And 3 by 0 is going to give me 0. So when I work that out, that's my first answer there inside of the solution to the question. Now let's look at underneath here now. So remember I said this is row 1, right? Let me just put row 1 here. This is row 2. So we're going to deal with row 2 now. We're looking at this row here. So just like I did before, we are going to do row 2, but we're still in column 1. This is column 1 we're looking at here. So we're going to match them again. First number in row 2 multiplied by the first number in column 1. I put circles to make it a bit easier for you to identify what is multiplying by what. So I have 4 being multiplied by 1. It's easy to know if you're doing the right thing because these two numbers here should match. Yeah, because we're multiplying by column 1 again. And then this is going to be 1, right? Because in row 2, this is my next number, second number, multiplied by 0, because that's the second number in column 1. So underneath here, I'm going to have 4, because 4 ones are 4, plus 0. So my number to the bottom here is 4. So I still have to fill here and here, right? So let's look at column 2 now. We want to look at column 2. So we are still in row 1, but now I'm going across the column 2 across on the side. So again, first number in row 1 is going to multiply by the first number in column 2, right? So let's just put a circle there so that we know what we're doing. So we have 2 being multiplied by 2, right? Plus, because we need one number here, so we can have multiple. This is the second number in column 2. So I'm going to add this second position in row 1 with second position in column 2. Sorry, multiply 3 multiplied by 3. Going to do the same thing for row 2 and column 2 now. So I'm matching. Row 2 has 4 circle, right? And I'm going to multiply it by 2, which is another circle, right? 4 and then 2 plus, because we just need one number here. We're going to deal with this bit here. We have it in a rectangle, second position in row 2, second position in column 2. So we're multiplying those two together, 1 and by 3. Again, let's look at the patterns, guys, because this is all about patterns, right? Look at this pattern here. This is my column 1 numbers, 1 and 0. Notice that I have the 1 and the 0. And then it matches underneath here 1 with 0. Similarly, column 2 numbers is 2 and 3. Look at this. I have 2 and I have 3. And then I'm repeating again 2 and 3. These numbers here, sorry, let's get out of. These numbers come from my rows. So row 1 should always have 2 and 3. This is still row 1, so I'm still multiplying by 2 and 3. See that pattern? And then row 2 numbers is 4 and 1. So look at this. Underneath here, I have 4 and 1. On this side, I have 4 and 1. You see the pattern? Now, once we follow the patterns and then we just do our usual arithmetic, everything falls into place. Because underneath here now, look at what I'm going to get. I'm going to get 4 plus 9. And then I have 4 twos are 8 plus 3. Right? And all of this comes down and back to my 2 by 2 matrix, because we said that the numbers on the outside tells us what is the size of the answer or the order of the answer. So we have 2 and 4, and 4 and 9 here is going to give me 13, and 8 and 3 is going to give me 11. So my answer for this is 2, 13, 4, and 11. This is the answer here. Yeah? Let's look at another example. There's just two that I'm looking at today. What we did just now is a 2 by 2 matrix by another 2 by 2 matrix. Later on, when you do the solving simultaneous equations using matrices, what you would notice is you would have two matrices that you need to multiply. And one of them is going to be a 2 by 2 matrix like this. And then we're going to have, let's have 1 and 4, we're going to have a 2 by 1 matrix. This is a 2 rows by 1 column. Yeah, let me put in a different color ink. Right. Right, so this is 2 rows, right? You see any 2 rows? 1 column coming down this way, 1 column. This is a 2 by 2. We have 2 by 2, 2 rows by 2 columns. These two are compatible, yeah? Numbers in the middle are the same. This is what I want to get at particularly, right? The outside numbers tells us what is the size of the matrix that we're going to get. So let's just draw a sketch of it, right? A 2 by 1 matrix should look like this. 2 rows, row 1, row 2, and column 1, right? So it means that if there's just one column, then there's just going to have these two values here, one for row 1, one for row 2, but it's just one column. How do I get the number for here? The number for here is going to be found, or we're going to find that number if we multiply row 1 values by column 1 values. And similarly, underneath here, we're going to have to row 2 values by column 1 values. So let's look at it. Right, let's look at it. I have 2. I think I need a bit more space here. I'm taking this off because you guys understand how you're going to check for that, right? Good. So let's try and follow the same format we did last time. Right, so I'm labeling to make it easier on my eyes. This is row 1, this is row 2. We only have one column here, right? Multiplying matrices is always multiplying the rows in the first matrix by the columns in the second matrix. So we are only concerned with these rows here being multiplied by this column here. Yeah? So let's look at it. Now, when I'm making this here, I'm remembering that my answer is only going to have one, it's only going to have one column. There are going to be 2 rows, but 1 column, right? So let's look at it. So first value in row 1 is 2. And I'm going to have to multiply by the first value in column 1, which is 1. I'm using circles so you can easily identify what is being multiplied by what. And then I'm going to do squares with squares. Second position in row 1 multiplied by the second position in column 1. So let's write that. So I'm going to get 2 multiplied by 1. Remember, I should just get one value for the top here, right? So to get one value, I need to add this. So I'm going to get 3 multiplied by 4. Right? I just did row by column. Yeah? And now I'm going to do the same thing. So that catered for my row 1. My row 1 is fine. When I work this out, I'm going to be able to get this value here. Whatever this value is supposed to be, I will get it from working this out. Row 2, right? We're dealing with 1 by 1, right? Circles by circles, positions by positions. And then the other one, I'm going to get 2 multiplied by 4. Now, what I always used to do just to make sure I'm not messing things up, right, is I always would check to make sure that, let's get a different color ink, that these two match. Notice that? They're matching. Yeah? Those two match means that I took the correct values from the columns. Now that we did this and we created, what our answer should look like, I can actually work it out now and I would have my answer. So 2 by 1 will give me 2, plus 3 fours are 12. 1 by 1 will give me 1, plus 2 fours are 8. Yeah? Now I can get my answer. Let's get rid of that line there, it's in my way. Right? So the answer to this question is going to be a 2 by 1 matrix that's comprised of 14 and 9. Yeah? Make sense to you? Let's just do one more for the fun of it. One more, and I am gonna do another another 2 by 2 matrix. 1, 2, 3, 4. How about we put in some negative numbers in here? -1, 0, 2, -2, right? So again, check to make sure it's compatible, right? Always check to make sure it's compatible. I mean, we know these two are compatible because we've seen them before. This is a 2 by 2, and this is another 2 by 2 matrix. And we have the middle values being the same. The end values telling us what our answer is going to be look like. I like to kind of write it somewhere on the paper. So I know I have an idea that I need one number there, one number there, one number there. This is what the matrix should look like ideally when I'm finished solving it. Yeah, when I'm finished multiplying these two. So let's get some space and let's multiply these matrices, right? So remember I said we're taking the rows in the first matrix and we're multiplying it by the columns in the second matrix, all right? Rows by columns, guys, rows by columns. So this row is going to multiply by this matrix. And when I do that, I'm going to get the first value here, my row 1, column 1 value, right? That's going to give me value for here. So let's see what it looks like. Again, I like to use these videos. So this is a circle, multiplying the same position. So I'm going to get 1 multiplied by -1, right? I'm going to have to add this because I just want one big value for here. I don't need a million values. And then we just visually, again, this is a rectangle, second position by second position. So we have 2 by 2. Right? So you see, this here, row 1 by column 1, gives me the row 1 by column 1 value in my answer. Right? Hope you understand how I'm getting this. When I want to get this other value here, which is really row 1, right, by column 2, then I need to do this again, row 1 by column 2, right? So first position by first position, 1 by 0. So I'm going to get something that looks like this. Remember, it's just one value we need for here, so I need to put addition sign. And now we're looking at 2, right? Second position in row 1 by second position in row 2, right? 2 multiplied by -2. Now we could go to our bottom row, row 2. So I need row 2 by column 1, row 2 values by column 1 values. I think you guys get the hang of it. So first position is 3 being multiplied by the first position in column 1, which is -1, right? You all know how the patterns go for this. So I can easily just look here. This is my second position in row 2, 4. And I'm going to multiply by the second position in column 1. Oh, yeah, I think I just have a little mistake here. This is a +2, right? Because column 1, when I'm multiplying by column 1 has -1 and 2. So I should be seeing this -1 here and 2 here. Row 1 has 1 and 2 as its value. So I should be seeing 1 and 2, 1 and 2, right? Row 2 has 3 and 4, so I should see that 3 and 4 here. I should also see it on this side because this is row 2, right? So let's just kind of fill in the blanks there because that's what I was saying. It's all about patterns. These two should match, so I could put that there, 0, 0, right? We add in everything. These two here should match, so I could put that there, -2, right? It's all about pattern recognition with this, guys. Ooh, that was really ugly. It's all about pattern recognition, right? Once you could identify the patterns, then this becomes very easy, right? Now we're just doing some basic arithmetic. 1 by -1 should give me -1 plus 4, right? I'll get 0 here, -4. We're gonna get here -3, plus 8, 0, minus 8. Yeah. So now I need to just work these out so that I could get to one matrix here now. With just one value here. I want one value here. That one value is going to be 3. I need one value here. 8 take away 3. That's going to give me 5. I need one value here. 0 take away 4. That's going to give me minus 4. 0 take away minus 8 is going to give me minus 8. Yeah? So this is how we multiply the matrices. Always rows by columns, right? So let's recap. Let's clear the board and recap. Right. So let's just put some points. First, to multiply matrices, we need to be able to identify the order of the matrix, right? And we do this by listing rows multiplied by columns, right? That's one. Then we saw after that, the next thing that we need to do is we need to look at compatibility, right? And in order for it to be compatible, we saw that in order for it to be compatible, we saw that if we have two matrices, 2, 1, 3, 4, and let's say we have another one here, 1, 0. For these two matrices to be compatible, when we write the orders of the matrix next to each other, the middle numbers need to be the same. The middle numbers are the same, we could multiply these two matrices. If the middle numbers are not, like if I change this, right? So this means that unlike regular numbers, integers, right? Where multiplication is commutative, the order doesn't matter. With matrix multiplication, it matters. Because look what happens here. When I change this around and I put the 2 by 1 in front, this is no longer compatible. It's not, right? So this would not work. We can't multiply this matrix. We can multiply these two because the middle numbers here are the same, right? And the end numbers here is going to tell me the answer that I'm going to get. So the answer for my matrix should be in this form. 2 rows by 1 column with whatever values that we got for here, right? Oops, I think I took something off that I didn't want to. Right, no worries, you can put it back. Right, so here we want to check for compatibility. Right, are the middle numbers the same? That's what we're asking ourselves there. Then after that, there was one bit that I think may have overlooked. What is the order of your answer? Right, what's the order of the answer? How many rows and how many columns is the answer going to have? And I know you know how to do that because we went over that a couple of times, right? And this, I think, is one of the most important things, understanding how many rows and columns is in the answer, because that's what I think confuses students. With all of that going on, they don't know what the answer should look like. How many rows, how many columns? So once you work out the order of your answer, what that allows you to do, right, is let's just say that I did a matrix like this, 4 by 3 by 1 by 2, and then I multiplied by the same example that I did before, 2 by 3, right? I know this is a 2 by 2 matrix. I know this is a 2 by 1. My middle numbers are the same, so that's good, right? And then my answer is going to have the order 2 by 1 matrix. So what that means is that when I multiply these two, the answer that I should get should be a matrix that just has a value here and a value here, right? 2 rows by 1 column, right? Whatever these values are here. That's what I should get. Now, once I do that because it helps me to work out now, how am I going to get those values? I need to multiply row 1 by column 1 to get this value. I need to multiply row 2 by column 1 to get this value. Understand? If I did a different matrix, like say I did 1, 2, 3, 4, right, multiplied by 5, 6, 7, 8, right, and this is a 2 by 2 being multiplied by another 2 by 2, right? We know it's compatible because we see this in the middle here. The answer should be a 2 by 2 matrix. So that means I should have a matrix that has column 1, column 2, right? A row 1 and a row 2. I should have an answer here, a number there, a number there, a number here, and a number here, right? Again, how do I get these numbers? To get this number here, I am going to have to multiply row 1 by column 1. So I'm going to have to multiply row 1 by column 1 to get, let's say this one here, right? I'm going to have to multiply row 1 because I'm still in row 1 by column 2 because I'm now in column 2, right? So to get that answer, I'm multiplying the values of row 1 by the values of row 2. And I'm matching. First value here must multiply with the first value here. First value here must second value here must multiply with the second value here. Yeah? Same thing underneath here. This is going to be formed by doing row 2 by column 1. This one is row 2. Sorry, row 2. Just rub that off. Right? Row 2. To get this value here is going to be row 2 by column 2. That's how I'm going to get those values there. Yeah? All right. So let me take some of these things off. And then we just wrap up. Right. All right. I think that's about it. Yep. Right. Nice. So, right. When multiplying, we multiply the rows in the leading or the first matrix by the columns in the second matrix. Yeah, makes sense? I think it does. Right. All right. So that's it. That's basically what we did today. We looked at identifying the order of the matrix, right? And we look at that by looking at rows and columns. Then the next thing now we look at is compatibility. Are the middle numbers the same? And then we look at what is the order of the answer, how many rows and columns in the answer. And then when we actually start multiplying, we multiply rows, right, by columns. And it must be the same position. So position 1 in row 1 must be by position 1 in column 1. Yeah? Position 2 in row 1 must be by position 2 in column 1. And we always multiply rows by columns, rows by columns. All right, guys, so that should sum it up. I'll probably give you 1 or 2 questions that you can try on your own. We will do another video again where we may recap this a bit and then go a bit further into the matrices topic. I hope this was useful to you and that it clears anything up in terms of your matrix multiplication. If you have any concerns or queries or anything now you'd like me to go over on this, you could always send us a message. All right, all the best, guys. Take care.